All right, guys. So let's start the next topic now. So we'll finally now discuss about tree diagrams. So we have been learning how to work with Venn diagrams so far, right? So we use Venn diagrams. So now tree diagram. So a tree diagram can be used to show the outcomes of two or more events happening in succession. So if you have two or more events happening one after the other, successive events, we can use the help of tree diagrams. Okay, so I think you already have some kind of a basic idea about using tree diagrams, but anyway, let's quickly, go through the basics. All right, guys. So we'll move on to exercise 4, question number 1. So basically, all the theories you learned previously are still applicable even in the tree diagram. Okay. So all the theories that you learned so far is applicable. So we'll learn how to actually use those in the tree diagram. So they say here, Khan takes part in 2 cycle races. Okay, so these are the 2 successive events: first cycle race and the second cycle race. The probability that he wins the first race is 0.6. The probability he wins the second race is 0.7. Work out the probability that he wins at least one race. Okay, so we are supposed to actually do this by using a Venn diagram. Okay, so what do we do here? So in a tree diagram, you have branches, and these branches, do you recall? They should give out the total probability in the branch, in the 2 branches, or if you have 3 branches, if there are 3 outcomes, 3 branches. If there are 2 outcomes, there are 2 branches. So now if you consider a race, what are the events, what are the outcomes that you have in this race? So they say the probability he wins the first race is 0.6. So winning is one outcome. So if winning is one outcome, what is the other outcome? So basically in a tree diagram, the branches give the outcomes. What are the possible, what are the possibilities? What can happen? So if winning is one outcome, then the other outcome is to lose. Are you with me? So if winning is one outcome, the other outcome is to lose. Okay, so winning is the first outcome. So either you win the first cycle race, the first race. This is the first race. Either you win the first race or you lose it. So what's the winning probability? Winning probability is 0.6. And this is the place where you have to understand if you are winning, the probability of winning is 0.6. Guys, you should know total probability is 1. So if winning probability is 0.6, what's the remaining probability? What's the remaining? The remaining probability is the chance that you will lose. So if 0.6 is the chance that you are winning, what's the chance that you are losing? The chance that you are losing is 1 minus 0.6, right? Total probability adds up to 1 always. So the remaining portion, of the probability is the chance that you will lose. So this is 0.4. All right, guys. So this is the first race. Either you win the first race or you lose it. Okay, and then after you're done with the first race, guys, we will move on to the second race. Now, these are successive events. Successive events that happen one after the other. So, the first race, either you will win or you will lose. And then what's happening is you are going to go to the next race. So, the next race is the second race. So, second race also you have 2 options. The probability he wins the second race is 0.7. So, second race is happening after the first race, right? So you can see for second race, we can draw 2 pairs of branches. Why? Because one pair, one branch you can draw. Okay, so depending on the first race, we have 1. If you won the first race, what's the chance? Well, I mean, what's the probability of things happening in the second race? So second race also you will win or lose. All right, or else the second race can take part after you lose the first race. So first race you have lost it. So the second race, you can win or you can lose. So winning probability. So they say the probability he wins the second race is 0.7. So winning 0.7 means losing 0.3. Winning 0.7, losing 0.3. Can you see, guys? So this is how it works. I think you need to understand that the second race, we draw two branches, because depending on whether the first, depending on the outcome of the first race. First race, if you won, you take second race, you win or lose. First race, if you lose, so the winning or losing the second race. All right, guys, can you understand? 0.7 here, 0.3 comes. That's the remaining probability, right? Okay, so work out the probability that he wins at least one race. So what do you mean by winning at least one race? Winning at least one means what? Minimum, you should win one, or you can even win what? At least one means one or more than one. So these are really important terminologies. One or more than one. All right, so this is the meaning of one. Either you can win one or you win more than one. What do you mean more than one here? You only have two races. Either you win one race or you win both the races. Is that okay, guys? Either you win one race or you win both the races. Okay, so if you recall, how do we calculate probabilities in tree diagram? Along the branch, do you recall in tree diagrams, along the branch, probabilities must be multiplied. Do you recall? Along the branch, probabilities are multiplied. So what happens in the first branch? What happens when you go along the first branch? If you go along the first branch, the first race you win and the second race also you win. So in this branch, it's win-win. First race also you have won, second race also you have won. So that's the best possible outcome, right? You have won both. So what's the second branch? In the second branch, the first race is won, but the second race you lose. Can you see? So first race is won, the second race you lose it. Third branch, if you go in the third branch, you can see that you have first you lose, the first race is lost, and the second race you win. First you lose, then you win. Can you see, guys? And the last branch is the worst possible outcome, right? You lose both the games. So first race is also lost, and the second race is also lost. Can you see, guys? So this is the last outcome. Okay, so then what's the probability of winning at least one game? So guys, if you look at this branch, if you lose both, do you even have you won at least one game here? In this branch, have you won at least one game? Have you won even one? No, right? So then this branch does not come into our question. And the next one, so in the branch lose win, you can see, have you won at least one? A minimum of one? Yes, you can see you have won one game. Yes, that works. The second branch, have you won at least one game? So win, lose. So you can see you have won one game, right? At least one. Yeah, you have won at least one. And the first branch, win, win. What about this one? Have you won at least one game? I think you can see that you have won both the games. So one or more than one, you have won both. So that's also coming under at least one. Do you agree, guys? All right, guys. So these are the three branches you are concerned. So what did I tell you? Along the branch, you multiply the probabilities, and between branches, you must add the probabilities. So this is the rule. So winning at least one, what are the chances? You need to take the first branch, win-win. So this is one option, or you can win-lose. This is the second option, or you can lose-win. So these are the three branches you need to consider. All right, guys. So take the probabilities of these three branches and add. Along the branch, probability should be multiplied. So win-win. So the first probability of winning 0.6 multiplied by 0.7. Can you see, guys? You multiply. So this is the probability of winning both the games. Plus winning the first game, losing the second is 0.6 into 0.3. Can you see? 0.6 into 0.3. That's the probability of the second branch. Plus the third branch, probability first you lose and then you win. All right, guys. So all you have to do is what? Type this in the cal and get the answer. So just type this whole thing in the cal and get the answer. So that gives you the probability of winning at least one race. Okay, so that's the probability of winning at least one race. You can get this answer. Or another way to get the answer, another way to get the same answer is, guys, I hope you understand. Total probability is always one, right? So if the total probability is 1, can you see that all these 4 branches, the total probability of all the 4 branches must add up to 1. So what's the easiest way to get it then? From the total probability 1, can you see if you subtract the probability of losing both games, you get the remaining 3 branches, because all 4 branches must add up to 1. So from the total probability 1, if you subtract the probability of losing both games, guys, you get the remaining probability of the remaining 3 branches. This is actually the easiest. So because you don't have to, I mean, both methods are fine because it's quite a simple sum. So lose means 0.4 into 0.3. So you should notice that both of these methods should give you the exact same answer. So we are getting 0.88, right? I think I see that 0.88 is the answer. Both methods give you the same answer, right? Can you check? Should give you the same answer. All right, guys. Okay. So I hope this is clear.